So in this college algebra review, we should probably take one where it's not given in the graphing form. You're going to have to put it in the graph form and then graph it. So first of all, you look at this and you say, this thing looks a little weird to begin with because it's sort of jumbled up here. We need the y squared, I guess is going to be first, minus the x squared. And then we know that this is going to be a hyperbola. But we're not sure until they get all the numbers straight whether it opens up and down or right and left. Looks like it opens up and down right now. Let's find out though. So let's take this y squared minus 4y, because we have to complete the square to get that x minus h and y minus k quantity squares. If there were a coefficient here, we'd have to factor that out too, maybe. The next one will do that way. Oops, and this is minus x squared plus 8x, and then equals 4. That's probably why they wrote it that way, because we're going to have to add something to this also. And that means we got a couple things to add here on the right. But when we're doing that, you got to be careful of this negative. This is the y squared minus 4y, and we're going to add half the coefficient of the middle term and square it. Minus, and now we're going to pull that negative out. It'll be x squared minus 8x plus something, half that term, which is 4, squared. Now, what do we add on the right side? Well, if we had any coefficient out here, we'd also have to multiply that. We'll do one like that. But we're adding 4, and we're adding a negative 16. So it's going to be 4 plus 4 minus 16. Does that make sense? So this is y square root minus sine 2 square root squared. And this is x square root minus square root. Excuse me. Squared. On the right side, it's a negative. A negative 12. But this negative 12 is why you can't always be sure from that initial look which way, because we got to divide by a negative 12, everybody. So now these negatives cancel, and this becomes first. X minus 4 squared over 12. Well, we want really the square root of 12 squared. Minus, from this one, the y minus 2 squared over 12, but we'll do square root squared, equals 1. Does that make sense? So, this then, we know what the center is, HK. It's 4, 2. Remember, those negatives are important. This is the graph form, so that's going to be this thing right here. It opens right and left. Oops, that's center. The value of A is always underneath the x from e square root of 12. The value b is also square root of 12. You wouldn't have screwed this one up. But we can start graphing this so we can get the rest of these things. So this is 4, 2, and to the right and up. So this is the center. A is 12. The square root of 12 is 3.46, approximately. So I'm going to go to the left and the right about 3.5. Okay. So 1, 2, 3.5, someplace here. 2, 3.5, someplace here. Up 3.5. That's going to be my rectangle. In this case, it's a square. Put in the diagonals, which are the asymptotes. And this is where opening right and left becomes real important. Opens right, approach the asymptote, and left. Approach the asymptote. Okay. The vertices are these points right here. It is, see, this goes right and left about 3.5, right? But that's the square root of 12 here, right? And this is the point 4, 2. And these are square roots of 12 here. So we're going to use the square root of 12 to figure that out. So this vertex is 4 plus the square root of 12. And 2. It's also 4 minus the square root of 12. And 2. The foci, we have to figure out what C is. Because this is the right triangle, square root of 12, square root of 12. Square this and square this, we get 12 and 12, which is 24, which is what that's supposed to be squared, the square root of 24C. So, square root of 24. Which is 4.9 about 5. So from here, someplace in here, and someplace in here. That is the square root of 24. Square root of 24. So the coordinates of the foci. It's 4 plus the square root of 24 and 4 minus the square root of 24. But always 2. The asymptotes, we're going to use the center for 2. So it's going to be y minus 2. And then the slope is rise over run. These are both the same. So the slope's going to be 1. So I can put a 1 in here. And x minus 4. For the other negative slope, just put a negative 1. And those are the equations of the asymptotes. Can you do that on a test? That's a good question.